How are you doing? Good afternoon, everybody. Hope you are still with me.
Yes.
So what I will do right now is, it looks like, it's end of the day. So what I like to do is make it more engaging with you, right? So let me start with a question. If there is a network that you would like to see, what would that abstraction be? What would you like to see in a network that happened? Anybody can give me any attribution? What that network would be? The network of the future. Imagine, take your mind to there. What this future will provide you? Anybody?
That you don't have to configure it, you just plug it together and it works.
Zero touch provisioning already there. Anything more than that?
No wires.
No
No wires. It's just me in Amsterdam, yeah, and some like things available instead of.
Yeah.
Of course, we can read, yeah, and self-oriented everything.
Yes. So a future of a network would be self-help, self-configured, something that will able to fix itself. And that abstraction is right there right now. Actually, AI, artificial intelligence, is already being integrated. And I'll give you the brief of what's happening in the network. So today's session is not about talking about Agema. I would like to make it more educational so that I can interact with you, give you the perspective of where network is going and why OCP has, OCP actually given a birth to a fundamental things, and that fundamental thing is open networking. Open networking. Open networking can be taken as the building block of what future has to offer. A lot of people think that SDN has given the birth of open networking. It is not actually. The service providers and in general the industry felt, and I was when I was working for Nortel as an architect, we have contributed to industry with so many different things. Policy enabled networking. Now we'll go with each of them. ATM has phased out. When you take a technology and you wanted to push it through, you need to look at what is its purpose, what problem it's solving, right? ATM became very complex. SAR technology couldn't take hold in the chipset. It was very difficult to implement. It was expensive. So ATM fall down. Do you think SDN will fall down? No. There is a purpose as to why SDN is coming to exist. And it started from an experiment in ethane project. And I'll go over it. So what open networking is doing is innately it will reduce CapEx and OpEx of your network through the disaggregation model. And that is important. And OCP has provided a platform for industry to contribute, both in software as well as in hardware. And this is paving the way for everybody to take benefit of this disaggregation model. Rather than being bogged down by a closed system, you are now suddenly open. And with this openness, it is paving the way for programmability to occur, because now software vendor like IP Vision, they can focus on what they do best. Hardware vendor like us, we could focus on what we do best. And this is called network decomposition. And through this decomposition, each subsystem can able to do what they're supposed to do, and then we can able to easily integrate. And that's why standards are created, APIs are created, protocols are created to bring them together. So SDN and NFV has two different purposes, and I will discuss about it. And what it's doing is that, and service provider leading this market, I talked with a lot of service providers around the world, and service provider say, okay, what I need to do is I need to create a future of a network. I need to create a service. And they call it intent networking. It's coming. And intent networking is the beginning of intelligent networking, which would be self-healed, self-configured, built on artificial intelligence, and it can able to make determination of how the traffic can be moved forward. So intent networking is actually, it started to happen, although I put it 2020, which it will materialize. Intent network started to happen. And I'll talk about a little bit on one of the service provider that implementing it or want to implement it. So I just gave a glimpse about open networking. Open networking is moving away from locked system. Merchant silicon is paving the way for you to now get into a very different kinds of system, the system that opens up. You will create, so what we have done with this hardware model based on open silicon, the reason I'm talking about open silicon is that there are certain silicon that you could able to actually access them, like OpenNSL, one of my colleagues talked about it. There are other things that is done like SAIs, switch abstraction interface, and so on and so forth. There are harder abstraction layers being created, and industry is contributing through OCP. And OCP is actually contributed through the form of SAI to the industry, so allowing you to map certain tables even to the upper layer. OpenNSL can provide you APIs for upper layer, so does the SAI can provide you APIs for upper layer. So this abstraction is called open networking. Not only open source as a point of view, but the point of view that how far you could do. You know, if you have an imagination, it is possible. Nothing is impossible nowadays. So what we are providing only open network install environment with the dial tools, and the NOS vendors like IP Infusions, they need support. We provide that support to integrate their NOS in our hardware. But beyond that, we are also contributing OFDPA and so on and so forth. So if you have to buy a hardware from us, you can buy a hardware from us or XYZ. You are not bogged down by, okay, I bought a hardware today from Agema, what do I do? I have IP Infusion software, or I have ICOS software, or someone else's software on this. That what you are getting is a choice. You can take this hardware today, and if you do not like this vendor, you can throw it out, take another hardware. You have the same software you can use. For example, if you have IP Infusion software, you could use. You do not like IP Infusion software, you could put ICOS software or any other vendor for that matter. So the flexibility is enormous in that regards. It's giving you a choice, and that choice is important for service provider as well as for even data center. Although the need of service provider actually differs from that of a data center. So what we are doing, we have different class of product line. We have provided ONI and dial, and we have two different packages now. One package is ONL based, ONI, dial, another is Debian based, and we have contributed both of them. Specifically ONL based one for Qumran based platform, we have contributed to GitHub. So you could download that, you could do your own experimentation. We are also working on OFDPA based platforms. There are certain constraints with it. For example, OFDPA innately port mapping. So in the front panel of the switches, there are lots of ports. OFDPA cannot identify those ports, so we are trying to see how port mapping can be done. But OFDPA can only see CPU-based port, which is management port. So you could use a controller to program it, but you could not connect your controller to the network port. You have to connect to the management port. That's the only difference. So, stages of SDN and NFV, what's happening? As you see, separation of hardware and software, paving the way for everything to materialize. Decoupled is what we are talking about, open networking. Control separations and programmability is SDN. Cloudification, where you integrate Openstack and so on and so forth. And decomposition of network, as I talked about, that's where policy-enabled network comes in. I want a service. The intent of my network need to accommodate the service that I do want. So, any question here so far?
Dhiman,
Mm-hmm.
let's assume this is a perfect world and everybody agrees. OCP is going to be the future. What's, in your view, the perfect migration?
In terms of, there are two different kind of world that we can see. One is NOS-based world, another is API-based world. In fact, one of the service provider I talked with, and I've also talked with my colleague Joanne's here, there is a different future also coming, where the service provider wants an unified abstraction layer like SAIs, but extending over CPUs, even controlling fans, power supply, all this information through a hardware abstraction layer, and then creating the API for upper layer. So the two different worlds that they do want, one is NOS-based world, another one, what we call metal networking. It is bringing the power of the metal without so many software layers to the cloudification software. So that now you could access without having to have so many sauces there. Think about a burger. You put too many sauces, it's gonna get ugly. But use unique balance of spice and other sauce, it will give you the flavor that you want and the taste that you want. And with the metal networking, this is another thought process coming to the industry is that can we do like metal cloud? There is a company started called Big Step. They started metal cloud. Can we do something like that in networking? And that thought process is already started. So we are looking at traditional world, actually a mix of traditional and non-traditional world, which is based on hybrid NOS, where you have an OpenFlow agent and you have traditional software, and then you have a purely API-based world. That's going to be something that's coming next. All right. So here is the SDN ecosystem, open networking ecosystem. At the bottom, we have differentiated portfolio of switch. I just put Agema name over here, but it could be anybody's name. On the top, you have hardware abstraction. You see different kinds of hardware abstraction. OpenNSL, SAI. OFDPA is not quite hardware abstraction. There is a bottom of it is in hardware abstraction. Top of it, it has in between certain metadata. And then top of it, it has protocol agent. Indigo being one of them. Now, recently they are using RU agent, RU controller-based solutions for OFDPA. FBOSS is actually contributed by Facebook, and FBOSS uses OpenNSL and SDK mapping. There is a reason they wanted to do this. As I said, getting to the metal. Facebook started it. Not only Facebook, other people are also doing that. FBOSS being one of the contribution to the industry and a contribution to OCP as well. The next one is Big Switchlight OS is not quite near to FBOSS or OFDPA, but it's their own version of OpenFlow-based solutions. But one of the important one, and I talked with one of my colleagues here, is FORCES, forwarding control element separation. That particular one, FORCES, actually is the older one. Before even SDN started, Ethane project started, and Ethane project, the researchers were experimenting how to create elastic routing architecture. If you look at OFDPA model or any other model, you are pushing your thought process, meaning controller's thought process on the switch. Switch has no way of communicating back what it can able to support, what capability it has. FORCES provides the way for switches and the controller to exchange their viewpoint. Yes, I do support this. I can able to take the command line that you are going to push me to do. So forces has two parts to it. One is for switch forwarding plane, another is for controller, and I put it up there. So the next level is the choice of NOS. There are open source NOS and there are vendor specific NOS. For example, PICA8, Cumulus, IP Infusion, Broadcom ICOS, SnapRoute, these are vendor providing those NOS. SnapRoute, of course, has some open source element to it. So the IP Infusion contributed to the industry, both Quagga and Zebra OS. Am I correct, Dimitri? So they have done significant contribution to the industry. Open switch, we are trying to see what we could do to support open switch, as well as Microsoft Sonic. Microsoft contributed to the industry with their own operating system. So the next level up, this is called network hypervisor. Why it's called network hypervisor? Because imagine a network that you do have, and so many different routers in between. If you have to look at from the top, it would be so ugly. This part, that part, that part, this part. How about there is a controller that sits in between, and you can just drag and drop a line from one point to end point, and that gives you the visibility. OpenVRTX has been contributed by OpenLab to the industry to provide you that kinds of visibilities and overlay. That's why it's called network hypervisor. And Flowise actually, Stanford experimented with Flowise. It was actually the early network abstraction level controller, but it couldn't do what OpenVRTX is doing today. So that's why a lot of people do not know about Flowise. Next level up, OpenDaylight, Root Controller, ONOS, and Forces, and a lot of third-party software. Any question? I'm going to give you a pause here. There are a lot of questions you can ask. Yes, please.
I mean, look, you talk about an ecosystem here, and it looks like there are far too many options.
Yes.
Why is that?
Far too many options.
Your view.
Industry is still pondering over what is the best way moving forward. So many contributions happening from the industry itself. So many people are working on it. For example, OpenDaylight, take for example OpenDaylight. OpenDaylight and Openstack overlaps in the neutron level. So and industry now thinking, should we give up the neutrons L3 forwarding mechanisms? And depends on OpenDaylight because both of them overlapping. So there is a collective thought process coming along on that. So as we move along, we'll see only few will survive, few controller will survive. Why I am emphasizing on OpenDaylight? Because there is a behind the scenes so many things happening. AT&T recently contributed OpenDaylight's integration to ONAP, Open Network Automation Platform. It is developed based on AT&T's contribution of eComp. Why I know all the inside? Because AT&T recently announced partnership with Agema systems. I didn't want to disclose this, but it is already there in the press release. They're choosing one of our platform, and it's not like I know it; it's everybody knows it. Probably John knows it, right? So, so it's OpenDaylight has a lot of flexibilities, but is that something that you could depend on innately right now? Probably not. It has a long way to go for reliability. But Beryllium's and Baron's, the recent releases, are much better than Helium and other releases. So if you ask me which one between ONOS and OpenDaylight, in fact, OpenLab, I had that question. If AT&T is taking Open Delight and contributing to the industry through ONAP, then what happened to Honors? Right? And I asked that question to one of the colleagues there at one lab. Their answer was not quite specific. Right? They said, well, it is for industry to make the choice, right? Which one to get. So to answer your question, yes, as we get experience on this, we'll decide which one we'll take. Whether people are going to follow AT&T, I mean service providers, and then enterprise and data center will follow through it, that remains to see.
Let me try to pose the question differently.
Okay, go ahead.
It's sort of a similar question, but I mean, if you look in the list, you have on the bottom layers, you have even more choices than at the
Up layer, yes.
I would have expected it's the other way around. I mean, if you go from sort of from a certain degree on, it's only one system, two systems which sort of survive. Looking at an operating system level for IT, sort of their bets are made, the thing is gone. Right? Then if it comes to application, you have a lot of choices. I would have expected to higher up in stack, the more choices you have. It looks like the opposite.
Yeah, well,
Why is that?
Why is that? Because we love traditional world, right? We wanted to do the open networking, but at the same time, majority of the deployment is on the traditional world. We need NOS. You see the number of NOS being contributed, and number of companies is starting the NOS to contribute to the marketplace as well. I mean, IP Infusion was there since 1992. I have been using in 1999. So I have been using in Nortel. I mean, their OCNOS version is recent, but they were in the OEM marketplace for a long time. So why they decided to come and just contribute to the marketplace at the same time, bring this newer version, because open networking is paving for them. This disaggregation model is helping those companies to bring in their NOS and compete with. Now you suddenly have a choice. Of course, you cannot apple to apple compare with Cisco's iOS or Junos, but Demetris will tell that their softwares can able to compete. So there are a lot of companies talking like that with their own NOS, that yes, now you have a choice. We'll go with Cisco or go with us, right? But you have a choice on software, choice on hardware. And when choice comes in, when more vendors compete, what happens? Price goes down, giving service provider the leeway, right?
Yeah, but we still need to make decisions here. And so it looks for me, it's not the market is not ready to make that decision at the moment.
There are certain yes.
One question about technology standpoint. Why you positioning Open Contrail between two different very important pieces of the cake? Yeah?
Yes, very interesting. It has capabilities to do what OpenVRTX does, right? Which giving you the hypervisor capabilities of network. At the same time, it's a full-blown controller. It competes with Open Delight.
But not the same feature set as Open Delight has.
Yeah, Open Delight has lots of southbound APIs. Open Contrail only have 2, 3, and I have it.
1.5.
One and a half. You consider. Well, XMPP is there, NetConf is there, and BGP is there, so you can make some choices there. Right. So that's the reason it has 2 portions. One of the reason I put it in hypervisor, you'll see Open Contrail can provide you the capabilities to do provisioning of VXLAN tunneling. And Open Contrail actually, of course, you can buy it from Juniper for the full-blown with support of VXLAN provisioning. But Open Contrail, as it stands today, is a force to reckon with, actually. We cannot ignore that, both sides. Although not at the Open Delight level, but it is something, yes.
Yeah, I think maybe a nice thing to mention is that we could, for example, give out IP Infusion's 60 days, what is it, trial at the moment?
It depends. It starts from 30 days or 60 days, but typically, if the customer is focused, we can give 60 days plus.
Yeah, and then we could do the same with like SnapRoute. You can trial it, and ICOS on the same Agema switch. So if you're not satisfied with the CLI or the API of one OS, you can easily switch even without buying. You can test it and see if you're satisfied. And there's a lot of choices, yeah, but you can also filter and then try a few of those.
Yeah. So certain choices, of course, although I put it in a layered description, let me see. So for example, Axos have connectivity to OpenStack, but it better goes with ONOS. Axos, ONOS, OpenVertex, they are actually from same ON lab. ON lab contributed 3 of them together. But if you look at in the industry right now, Openstack leading the way, right? Other ones are not picking up. So as I said, sooner or later, people are going to make their determination which one to move forward. In the cloudification level, Eucalyptus, actually Amazon took it and made their AWS. But OpenStack is also a force to reckon with right now, right? I mean, industry has accepted OpenStack. And it is being, a lot of line codes are being added and it's being very stable. The current Mitaka release is pretty stable. I experimented myself and I can tell you that is very stable. And I had difficult times with everything else and provisioning, but Mitaka release of OpenStack is good. So this is service extraction and service chaining is something has not been done yet. It is something the service provider wants, and it is something that I talked about that innately connects with intent networking. And this is where more and more you will see new startup coming in, new services being developed, and service chains are being created. But there are other ways to create service chains. I'll give you an example. Any question? No? So far. Okay. So I can go deep or I can just be on the surface. Ask me a question, then I can go deep down or surface. So this is an example what I wanted to do. And the reason I'm giving you that, because one of the customer I wanted to do this. Imagine, and I just said that take your mind and imagine, and this is not an imagination, that is a reality that I wanted to do, and it is possible. Imagine that you go to OpenStack Horizon dashboard. In Horizon dashboard, if you have created a network, it's very simple. Once you create the network, you'll see the network icon in there. Anybody familiar with OpenStack? Yeah, you have seen in Horizon dashboard how the icon that is being put. So imagine instead of seeing that icon, you see your entire topology right there, entire topology in the Horizon dashboard. Now what you do is you click on one of the switch and you see poof, something opens up, and that would be your netconf form. Now, Dimitris gave you a heads up on something about how their company is working with OpenDeli. Guess what? We are connected, right? So what can happen in here, and I'll go into technical details on this. So you can click on this and let's say a BGP form will appear and you can configure the BGP. So how it's going to be, it's going to be pushed through Neutron's plugin. We are going to create a small plugin, and through that plugin you could push it down, and then you could use netconf to configure the box, right? And it's so one thing within OpenDeli, you need to imagine OpenDeli has a northbound interface and then southbound interface, and not all so if you imagine it is a square box, so northbound API to connect to southbound API is not that straightforward. Some of them connect, others not. So what you could do is you could create an RPC call to connect the southbound API to the northbound API. So, and possibilities is there. I experimented with that as well. So now the future of seeing the world topology is possible. How it's possible? There are two ways you could do it. You could pass the LLDP packet to the OpenDaylight, or you could use OpenFlow DP Discovery Protocol, OFDP, and pass the topology to OpenDaylight. Through this, you pass through the plugin to the Horizon dashboard, and now you have topology. So you just imagine, you click, you could bring up the CLI, or you could bring up a form and configure it. So the future that we are talking about is not far. Actually, it is much more near. And the way industry is moving, this is, I mean, could be possible by next year. Right? Any question here? So you have now two choices. You could do the same using Contrail, right? Or you could do it with OpenDaylight.
What do you think strategically? Because you are speaking as visionary, yeah? What do you think? Because some of the guys are dreaming to have open vSwitch running on top of bare metal.
So,
what do you think about that ideas and that approach?
So I will tell you something about, and there is an article I wrote about OpenFlow, right? So OVS need OpenFlow. Anything with OpenFlow innately requires a lot of TCAM space. And TCAM is very expensive. And a product like Tomahawk level products, right? Unless you wanted to go upper class product like Qumran-based Jericho Blaze product, and that has external TCAMs. But internal TCAMs, if you are using TTTP of the OpenFlow, you will innately take away lots of tables. And the mapping of the table is not that straightforward either. So I see that industry is pondering whether OpenFlow is the best way or other APIs is the best way. And second part is what industry is trying to pick up. Right, that's what I see. And I'll give you an example as well. Any question here so far? Yes.
How does networking continue into the server? I mean, so far there is the bottleneck.
Networking continues in the server. I see, so one of the company I worked with, that is C-Plane Networks. And C-Plane was giving me that vision that we actually, Agema is partner of C-Plane. I find the companies and I try to be partner with. And so we went into several service providers together. And the imagination was that a lot of functions would be done on the servers, networking including, right? But we find out that more and more service providers wanted to offload things from the servers. And I do not know the reason. Everybody has their own vision and version of it. But more functions that they would like to do in there on the NFV side or VNF side of the world is something different. Like for example, BBU functions. They want to put it in a server, right? VVBU. VOLT functions. They want to put it on the server, but not the regular network elements, right? VCPE, for example, all the service provider wants, but they want it a different way. They want to provision an application right onto the switch, not on the server. That's how I see that from the customer feedback standpoint. So here is an example how you could use netconf to provision VXLAN tunnel on your servers. Or you could actually do, there are several ways to do this. The BTAPs, if you're familiar with VXLAN, there are 3 ways VXLAN will work. Static VXLAN, where you know the IP address of the other end, well-known UDP port, or the multicast, it depends on the PIM, or MPBGP, EVPN kind of scenarios, which IP infusion support. But if BTAP is on the switch and you want to provision all the switches, the best way to do that, you cannot go to each CLIs and do this unless you use MPBGP, VPN. Even you use MPBGP, you have to still configure VXLAN information on the switch. So the better way to do it using either Contrail would be the best way to do that, using netconf. So OpenDaylight, why cannot do it? Because OpenDaylight internally there is a complex behavior, might not be suitable in this scenario. But you could write certain RPC call or plugins to help you on that. Any question here? No?
So essentially, the switch needs to have a netconf interface.
Yes, and your software already have. There are RESTful APIs you can also use, but netconf is better way because see, netconf uses modeling capabilities from Young model, and so it is something that is constantly being used, and I am seeing everywhere else that it is being used.
And it is secure as opposed to REST API.
Yeah.
That is a very important.
Yeah, that is another aspect of it. But more REST is not depending on Young model, but netconf is, and the more reason is modeling is very important in service provider network as well as security. Here is an example based on what I know a service provider is doing. And what they wanted to do, as you see, they are implementing on the edge level. They're starting with edge and using this open networking platform. It gives innately them the capability, CapEx and OpEx is down, flexibility, what they would like to do. So what they're doing is that, so imagine this is not even 3G, this is even 4G, right? 3G would be 100. I was talking with the service provider and they say, oh, I need a 100 meg switch. It's 100 meg in 100 base T internet. What are you gonna do? I wanna connect with VPU that's providing me 100 meg, and that is serving 3G services. And I was like, is it? So, as you see, service provider has not upgraded their network. They have not caught up with the technologies that currently available. Now, it's a lot of investment for service provider, but open networking with open platforms, if they can, and they're already trying to do, accommodate this and trying to take it. Once they take it, they will drastically, their CapEx and OpEx will go down. Their revenue will come up because it's innately providing much more service capability than they can currently able to provide through their network. So this particular switch, you could imagine that what the service provider need is certain telemetry features. And there is a project sprung up called OpenConfig. And OpenConfig is a streaming model based on Young model, and actually it is derived from Kafka type of architecture. Kafka, if you know, from Apache. Apache is a open source, I would say, right? So in Kafka, there is a subscriber and publisher model. Publisher goes and provides that information to the subscriber, and so on and so forth. This is the same model with OpenConfig. So the switch, when it supports OpenConfig, service provider can able to create a model. They can see the entire model of the network, and not only the model of topology. Topology has not been created, but what the device support. And they can push that information, collect that information accordingly. And this is a deployment happening. I have not shown you the other side, but this is on the mobile side of the network, how they are deploying. Any question?
So, let me ask on OCP, the sort of interface cards you plug into the switch. Are there versions for long distance?
You are talking about optical side?
Any.
So only constraint that I do see, the higher the speed you go, for example, if you want 100 gig, 80 kilometer, there is none. You need to use transponder. So you can use a transponder, and then you could use a mask, right? And then, if it is DWDM, you could use transponder and mask, and then you could take over the lambda, right, on the other end. But if it is 10 gig, 80 kilometer is already solved, right? Right? It's a Z version. Yeah. But 100 gig, 25 gig, that solutions is not there. You need transponder. Specifically 100 gig, I already seen the request. And for that, you need a transponder. And the irony is that a box could be, let's say, $10,000, 100 gigs switches, 32 board. But optics is also not expensive. But guess what? Transponder would be $13,000. And that's where drawbacks comes in. Industry is still trying to do this. And I know there are several projects Facebook is working on, as well as it's on the OCP as well. Is there a committee being created, John, in terms of optics?
There is, and there's been work done on optics, but on engineering the pluggable optics down to, they've taken the 10 kilometer 100 gig optic that normally runs on a duplex single mode, and they've re-engineered it down, and there's a new OCP optic that only goes 500 meters, and it's an absolute fraction of the price, and that's causing a total transformation in the data center space. But to get involved with long distance transmission, that's where it's going to go out to the telco boys in the other organisations. We see we're stretching ourselves too far to get into those 80 kilometre. A data centre really has got no need for anything longer than 500 metres, even in the biggest hyperscale. So it's kind of outside of our territory. I don't see us bringing that.
Maximum maybe 1 mile. 1 mile maybe.
No, 500. Even the biggest ones I know is at 300 metres long.
Depends if you have to be
I'll show you. Even if you take the hyperscale data centers, they're normally 300 meters long. You put the central concentration in the middle. So if you plan it wrong, then 500 meters is not enough. But if you plan it right and optimize the positions with the configuration of the hardware, then you never exceed 500.
Yeah. So as you see on the previous slide, I gave you a hint about intent networking, right? Right over here, you see the intent-based configuration flows, how it's being created. You could get the details if you go to openconfig.net, you'll get the details about how OpenConfig works, what is the architecture model, and how it could be supported. So here, what I have given you a perspective. As you know, central office reimagined as data center, a lot of people have talked about it. These are the 3 areas the changes are happening. If you look at these RODOM things, there is an open forum being created for RODOM. It's for add and drop multiplexer. It's a reprogrammable one that you could do for lambdas. And there are a lot of details about it is available, but for enterprise card, this is how it is implemented. And for residential card, how it's implemented. And I gave you an example on mobile card, how it's gonna happen. And of course, you see the centralized DPC functions already started to occur. Virtual BBU functions are already people are trying to move it to the server. eNode B functions, similar, is moving to the server. So either way you look at data center or the card, we have the portfolio of switch that fits in all. As long as you adhere to the class architecture, you could do. But we also have a 1 gig platform, PoE platform, and so on and so forth that can be used in scenarios, as you deem fit. So
can I just take you back on that last slide?
Okay.
Just quickly. There's lots of questions that keep coming to me from this morning, and it's about what are the impacts? How do I transform my enterprise data center to an OCP data center? It impacts lots of subsystems, and one of the subsystems that people are not aware of is the way you have to create this fiber non-blocking cross network. And people are forgetting about that, and it has an enormous impact.
definitely.
Asking questions afterwards. You have to consider all of your subsystems when you do the transformation.
Yeah. So in the class architecture, there is 3 tiers of spine leaf architecture being created. Facebook recently introduced a thing called super spine on top of the standard spine. So through the super spine, if you have a network with super spine, you roll in the pods, it's not going to impact the super spine. You could literally confine your configuration changes within the pod areas. So there is a network configuration of clause, and there are articles written about it. If you search on FAT tree architecture, 5-tier FAT tree architecture, and so on and so forth, you will see a lot of clause architecture being discussed there. What is the drawback on each of them, and how do you define a class architecture, right? Yeah.
When you mentioned the word pod, there's a rack configuration in OCP configuration where you're forced to put cabinets in certain grouping structures, and that has another impact on the physical implementation. Now, again, it's short today, but perhaps we'll cover it in questions afterwards. But the implementation of this fiber network actually tells you how you have to put the racks in the white space.
Okay. So I'll briefly go over what happened in our 100 gig portfolio right there. So we have, so I'm just going over our portfolio product quickly. And you can ask me question on each of these chipset if you would like to, or we could have, I can provide you details on that later. So we have a Tomahawk platform, which is currently available, is a 9032 Tomahawk based platform, is a 32 port Tomahawk, which is 3.2 terabits backplane. We are coming with this 20 port Jericho Plus. 20 port is a unique configuration, so definitely it's a service provider, right? So it's a service provider wants that particular product, and you guess who? You'll know that. And that one also has a Broadwell CPU on it, so giving you the flexibility to do a lot of programming capabilities, right? A lot of things you could do. And Jericho Plus innately provides you traffic engineering capability. Both Jericho Plus and Qumran, you could do traffic engineering. You could literally get into their APIs if you know SDK very well, you could be able to do that. Apart from what NOS vendor will provide you. So the Tomahawk platform, Tomahawk 2 is a 64 port 100 gig switch. Guess what? 100 gig is not end here. There is a 400 gig coming. 32 port 400 gig chips, ASIC is already available. People are working on it. So 32 port multiplied by 400 gig. Look at the terabit backplane, 12.9 terabit backplane. And then one RU pizza box. And I talked with the customer and I asked them what you were going to do. They said, I'm going to create a super spine, 400 gig super spine based on that particular switch. So apart from that, we have a 25 gig portfolio of product line. AG5648 is a Tomahawk based platform, 25 gig. We have a Jericho Plus platform on 25 gig. But when you see Jericho Plus platform and here, and of course, we talked about Qumran as well, innately you know that there are a lot of capabilities on it. External TCAMs comes with it. We'll talk about that. And as well as it has traffic engineering capabilities. It is in 2 versions. It's available, Sync E and non-Sync E. Sync E also comes with 1588. So if you are using somewhere you need clocking mechanism, you could use those products there. 8032 is a 40 gig switch. I currently see 10, 100 or 25, 100. I see less of 40 gig. The reason is that 100 gig is a 429 gig channels. Counting the loss, you can come to 25 gig, but it's actually 28.9 per channel. So if you are using 25 gig, 425 makes 100 gig, right? You use 10 multiplied by 10, it gives you the 100 gig. But if you are using 40 gig, you can, I need to break it down to 10 gig. Otherwise you lose it. All right. 7648 is a Trident 2 based platform. All those platforms supporting this one, Tomahawk, everybody do support MPLS, VXLAN, and so on and so forth. All the traditional features and bells and whistle that you want is supported. Anything below Trident you go, it will not support it. So we talked about Qumran a lot. Qumran is like a hot cake. Everybody wants Qumran, right? We have two versions. One is Sync-E and non-Sync-E, and I can give you details example if you want to. So these are Calyx 4 is a single chips. It has Mac and the CPU ARM9 processor built in. So these will not support MPLS and features like that, but they're pretty good at for the front end. If you're using for mobile towers and so on and so forth, you could use them pretty well. And here is an example of how the switch has been designed, specifically Qumran level switch. As you see, there is a Sync-E interface built into the Qumran, giving you innately capabilities of adding the fan-out buffers and other stuff, but the processing is offloaded to IDT. But the built-in interface is there from the Qumran for Sync-E. Two external TCAM will give you the capability up to 1.5 million routes IPv4. As you see, with 1.5 million route, you could literally create this as a core router, depending upon the scenario that you would like to do. So for the price point of a core router versus a price point of an open networking platform, you innately see how much you can save. It also have 4 GB of GDDR5 based packet buffer. And the packet buffer is what happens is that it's dynamically allocated to the port, giving it capabilities of lossless Ethernet, right? Packet buffers, when you oversubscribe, you need the packet buffer, right? In a microburst scenario in a data center, you want to hold the packet so that the packet doesn't get lost. Like Hadoop scenarios and so on and so forth, you could use those packet buffer would be automatically allocated here. But as you see, Qumran platforms does not have a bigger backplane. This is just a suggested 640, 100 gig. You need to calculate into the account that Qumran is not in 1 terabit switch. It is a 790. So you use those ports accordingly, right? Any question there in terms of its design? And as you see here, 32 gig of SSD drive and 4 gig of DDR3, meaning most of our boxes has Linux on it, right? IP Infusion uses CentOS, ICOS uses Debian OS like Ubuntu, and so I can give you an example, and Dimitri, you can correct me if I am wrong. Given the space over here, customer can able to put their own Linux tools, right?
Actually, we're using Debian Linux.
Yeah, Debian Linux, yes. So in ICOS, when it boots up, it goes into full-blown Linux. You could put Wireshark or certain other tools in there. So you could use TCP dump to get information and so on and so forth. So it allows you, it gives you a lot of flexibilities in terms of what you could do with an open networking box. Any question? Not so far? I think I am done. Thank you. Now I'll give it back to Milo if there is no other question. No question.
Thank you, Dhiman.